In this lesson, you will learn to solve polynomial equations. Now, in order to solve polynomial equations, we need to discuss a property called the zero product property. Now, to illustrate, imagine that we had two numbers, where the first number we'll call x, and the second number we'll call y. And we were to say that x times y equals 0. So you know that when you multiply two unknown numbers together, you know that the product is going to be 0. Well, what do we know about the two numbers? Well, we do know that the only way to get 0 out when you multiply two numbers together is if either one of the numbers that you're multiplying is equal to 0. So we know for sure that either x is equal to 0 or y is equal to 0. Because when you multiply, that's the only way to get 0 out as your solution. So with that property in mind, we can solve any sort of quadratic equation, where, for example, we were to have x times x minus 2 equals 0. So in this case, we have two numbers, just like we did before. We have, in this case, number 1 is going to be x, and then number 2 is x minus 2. And when you multiply them together, we know that the solution is equal to 0. So what does that mean? Well, we know that either one of the two numbers must equal 0. Either x equals 0 or x minus 2 equals 0. So my solution for x would be x could be 0, or if x minus 2 is 0, we can solve this by adding 2 to both sides, and we have x equals 2. So my solution would be x equals 0 or x equals 2. And we can check our answer. If we put a 0 in for x, we'd have 0 times negative 2, which would be 0. If we put a 2 in for x, we'd have 2 times 2 minus 2, so 2 times 0, which would be 0. So x could be 0 or x could be 2. Here's another example. We have x minus 5 times 2x plus 3 equals 0. So we have two numbers multiplied together equaling 0, where x minus 5 is your first number, 2x plus 3 is your second number. And we know when we multiply two numbers together and the solution is 0, we know that either one of the two numbers must equal 0. So either x minus 5 equals 0 or 2x plus 3 equals 0. So we can solve this for x. So for the first equation, we can add 5 to both sides, and we have x equals 5. Second equation, you can subtract 3 to get 2x equals negative 3, and then divide both sides by 2. So now we have x equals 5 or x equals negative 3 over 2. And that would be the solution. Now the question is, what if it's not in this format already? What if it's not two things being multiplied together equaling 0? Well, if it's not, then we have to make it look like that. So for example, here we have x cubed plus 6x squared equals 27x. So we know by the zero product property that if we get two things multiplied together and equaling 0, then either one of the two numbers must be 0. So we know that we need to get this equal to 0 first. So to do that, I need to get rid of this 27x over on the right. So to get rid of that, I can subtract it over to the other side. So when I subtract it, now I have x cubed plus 6x squared minus 27x, and then on the right side, we have 0. And now from here, we need to factor. And that is why we've been factoring the last few lessons, is because now we can solve equations like this. So to solve this equation, I need a factor, and notice these three terms each have an x in common. So when you factor, the first thing you want to do is see if you can pull out the greatest common factor. Is there anything that every term has in common? So yes, there's an x in common, so we can pull an x out, and then in parentheses we're left with something. So x times something gives you x to the third power, and that something is going to be x squared. Because x times x squared gives you x to the third power. And then x times something gives you 6x squared. Well, x times 6 gives you 6x, And then if you multiply by an x, you now have x times x, which gives you back out that x squared. And then here, x times what gives you negative 27x? Well, that's going to be a negative 27. So now we have pulled out the greatest common factor. And then from here, we can factor this trinomial. It's a quadratic trinomial. And when I factor, we know it's going to be something in parentheses times something in parentheses. Where this first number right here, remember we have two numbers here, and then two values here. This first term of the first parentheses will be an x, and the second one will also be an x, because x times x will give you x squared. And then the second value for both parentheses, we know when we multiply, they're going to multiply to give you negative 27. So how do we get negative 27? And that's going to be 9 times negative 3. That's going to give you negative 27. Right? And that's going to add together. 9 and negative 3 will add to give you a positive 6. So it's going to be x and then plus 9 and then x minus 3. And then don't forget about the x out here in the front. So now we've factored completely. So now we have, in this case, three numbers multiplied together equaling 0. Same concept. We know that if you have three numbers multiplying together and the product is 0, that one of those numbers must be 0. So either x equals 0, x plus 9 equals 0, or x minus 3 equals 0. So when I solve this second equation, I get x equals negative 9. This other one, you get x equals 3. So my solution would be x equals 0, negative 9, or 3. And I can check my solution by plugging these numbers back in and finding that you would get true statements back out for each of these three solutions. So the question is, where does this apply? How can we use this? Well, we can use this to find what is called the zeros of a function. The zeros of a function is another way of saying the x-intercepts. So for example, if this is your function, f of x equals x squared minus 1 times x squared plus 3x plus 2. The graph of this would look like this, and the zeros of a function is the same thing as x-intercepts, so it's where it crosses your x-axis. So notice right here at that point, right here at this point, and then right here at this point. Those are all x-intercepts, or zeros of the function. Okay? And so we can find those zeros of the function by solving equations like we just did. So when it says to find the zeros of a function, we know that it means x-intercepts. And we know that the x-intercepts, y will equal 0. So like here we see that x is 2, y is 0. Here we see x is negative 2, y is 0. And then here we see x, and actually, sorry, this is going by halves. So this is actually 1 and 0. This is negative 1, and this is negative 2, 0. So I noticed a scale on that. That was my bad. But we see here we have 3 points, right? And what I was trying to show is that the y value is 0 for each of these. So we can look at the graph and determine, where it's crossing the x-axis. In this case, it's pretty easy to tell. But if you don't have the graph, and if the graph isn't clear, you need to know exactly where is your x-intercepts going to be. So what we do is, if you're given a function like this, you plug 0 in for y. We know that y is 0. Remember, f of x is the same thing as y equals. So in place of the y, you'd put a 0. So let's try this. Here's your function, and you plug a 0 in for y. Now we need to figure out what is x going to equal. And to do that, we need to factor completely. And here it's not factored all the way, right? We should notice pretty quickly x squared minus 1 can factor. That's a difference of squares. So that would become x minus 1 and then x plus 1. And then x squared plus 3x plus 2, you can factor that completely as well. To get x squared, we have x times x, To get the 2, the only way to get 2 is going to be 1 times 2. And they're both going to be positive because when I add them together, I need to get a positive 3 back out. A positive 1 plus a positive 2 gives you that positive 3. So that would be factored completely. So from here, what we know is that we have 4 numbers multiplied together. The product is 0. So I can set each part equal to 0, where x minus 1 equals 0, x plus 2 is 0, or x plus 1 is 0. Okay, so then I solve this. X would have to be 1, negative 2, or negative 1. And those are my solutions. And we see that's the case. Right here, x is 1. That point is 1, 0. Right here, x is negative 1. So negative 1, 0. And right here, x is negative 2. So negative 2, 0. So based off the graph, we see that we have the correct solution.